Yeah, hi. And welcome whoever is listening. Hmm, I was watching some video about Nikolai Tesla and some guy who tries to rebuild things what Tesla had. And this triggered me to make this little video. It starts a little bit funnily. We are on Wikipedia, atmosphere of Earth, because I was searching for atmospheric layers of Earth, but I want to point out this because that's really neat. So this is our atmosphere 100%, okay? Of which 0.0407% is CO2. So that you understand, this part is so small you don't even see it here in the upper. It doesn't. It's too small. So 0.04% of the whole atmosphere content is CO2. And if you reduce it by using a bicycle, it might help really much, I guess. But you can make your own conclusions about that. I wanted to show something else. Here. What's going on? Center for Science Education. Layers of Earth atmosphere. That's the highest thermosphere. Then we have the mesosphere, where we have the sprites from thunderstorms and these kind of things. And down below we had the troposphere with mountains and the clouds and stuff. Okay. So if there's energy or particles or stuff coming from inside, some they stop here, some they stop here, some they stop here on the ozone layer. That's why we don't use certain things anymore, because obviously it destroys the ozone layer. Even though radiation can destroy it too. And then we have the troposphere layer. So I just mean stuff can penetrate through all of that and beyond. Okay, get it? So this indicates that stuff from here can go all the way up to. It's always an exchange of things. So, I was talking once about volcanic ash plumes acting like antennas. Here in this sketchy vid, I hope there's no sound because I don't usually watch my own videos. Yeah, that's what I tried to explain last time. You know, it gathers. We have stuff coming from the sun, like energy, charged particles, and such things. So now I want to show you now a part of a video that I was watching today, which might be this kind of how to put it, proof of me being right after all. I'm staring in that disbelief and wondering what in the hell just happened. But now let's continue listening with what he has to show and tell.
So, of course, the first thing we did was try to recreate the accident. We pulled the stored coil out and set it up here as the receiving coil. and the other coil we set up as the transmitting coil. And both these coils are tuned to the same frequency. And instead of a clip lead, we gave the receiving coil 800 watts worth of light bulbs as a test load. Now I thought 800 watts would be more than enough, but the receiving coil could actually drive these way beyond 800 watts if the transmitting coil got any closer than 5 meters. This made no sense to me at all, since the electric coupling between these two coils is so incredibly small. It measured about 10 femtofarads, which is 1/100th of a millionth of a farad. But later I ran some detailed circuit simulations, which confirmed that even this amazingly small amount of coupling can pass dangerous amounts of power between two well-tuned Tesla coils, all through the magic of resonance. After this discovery, a friend, Mike Kennan, felt rather strongly that light bulbs were a terrible choice for a test load. He thought this effect should be used to push his lazy butt around. So he built the world's first real Tesla Roadster. There's an aerial up here, and this aerial consists of a bunch of welding rods that form a disc shape, and that establishes an area where it can collect electric field lines that ultimately come from the transmitting coil. That energy goes down here to a little resonant transformer mounted on the frame. And this transformer can be quite small because the operating frequency is so high. The transformer steps down the voltage to about 200 volts or so and runs this 180 volt gear motor over here. And then the gear motor is just linked to the drive axle under the seat. That's all it is. Here's a short video clip of the Tesla Roadster in action at a Maker Faire a while back. Note that Mike is wearing heavy welding clothes. He kept complaining about getting shocks from holding the steering grips. It's too bad we didn't collect the energy from him as well. Oh, when the cart starts moving, you can see some lively sparking down here from the grounding chain that drags behind the Roadster.
There. So now let's go a little bit backwards in the video, because I want to draw something to it. It's already there. So now I want to try to explain what I meant. Here above, like if this would continue, he would have these antennas, which are metal rods in this case. Goes down, powering this vehicle, which goes forward, and besides that we have sparks here on the bottom where the grounding happens, and the energy is coming from this and this pillar, so it's going through the air, gets collected here, goes down to the ground, and it makes things move and sparks fly. So now let's have a quick look at volcanic ash. Fragmented rock minerals, volcanic glass, properties. The types of minerals present in volcanic ash are dependent on the chemistry of the magma from which it erupted. Considering that the most abundant elements found in silicate magma are silicon and oxygen, the various types of magma and therefore ash produced during volcanic eruptions are most commonly explained in terms of their silica content. Low-energy eruptions of basalt produce characteristically dark-colored ash containing 45 to 55% silica that is generally rich in iron. So iron reacts really well to electromagnetics. So let's go back to the video quickly again. Now imagine this would be the volcano. This is the ash plume, and we have those atmospheric layers in which it then gets, through its electromagnetic potential, gets locked into the layer. And this stick here, like that's the cloud, the antenna on this thing, Tesla Roadster. That's the cloud which goes into the volcano. And then we have the sparks inside, and also the movement inside the ground. So man and chair volcano, antenna ash cloud, sparks and movement. This is heat and this is movement. Magma is hot and moves. This is what I try to explain. Thanks. Bye.